All right, let's go ahead and get started. I want to welcome you back to Unit 6. We are learning about nomenclature, naming chemical compounds. Folks, you're going to need a periodic table for this one, so if you don't have one handy, go ahead and pause the video and we'll get started. So we want to take a look now at the transition metals. Remember, the transition metals were those that were in the P block of the periodic table, that central belly area of the periodic table, and they often have multiple oxidation numbers, otherwise known as charges, right? And we have to determine what the charge is for that transition metal so that we can describe it in the name. So let's take a look at this first one. We have PbCl2 and we want to name that compound. How would we name it? Well, the first thing to notice is that lead is a transition metal. It has more than one possible oxidation number or charge, and we've got to figure out what that is so that we can describe it in the name. So how do we do that? Let me write it just a little bit bigger over here so that we can see it a little bit more clearly. If I write lead chloride, if I say PbCl2 just like that, how did that, well, what should have been a 1 right there. Remember, we don't write the 1. But how does the 1 get to that position? Well, it got there because there was a switch done. In other words, there was originally a charge of -1 on the chlorine, right? And there was a charge of what on the lead? Well, the 2 must have come from here. So that means +2. So the charge on the lead then we now know must have been +2. So we have determined then what the charge on the lead is. It's +2. So now we can write in the name lead, Roman numeral 2, chloride, just like that. And that names that first compound for us, okay? So lead, Roman numeral 2 for the very first one. Let's take a look at the second one. We have silver and we have fluorine script 5. So, or excuse me, not silver, gold, I'm sorry, AuF5. So what we want to do is we want to be able to name this compound, but we need to know what the charge is on the gold atom. So how do we go about doing that? Well, again, we're going to write the Au, just like that, and F5. So what's the charge on the, what is the charge on the gold atom? Well, the 5 must have come from, this 5 must have come from here. So this charge must have been a +5, and you know that the charge on fluorine is -1 because it's in the 17th column, right? So that means we now know what the charge is on the gold. It's +5. So we say gold, Roman numeral 5, fluoride, and that's our final answer, our name for this compound, all right? So let's move on to the next one. We've got platinum and chlorine this time, and we want to know how to name this compound. Well, in order to do that, we recognize that platinum is a transition metal, right? It's a transition metal. And as a result of that, it has possibly more than one charge or oxidation number. And in fact, it does. So platinum, to determine its oxidation number or its charge, what we're going to do is, let me write the formula again right here. We have PtCl4. Now, where did the Cl come from? Or what was the charge on the Cl? Well, it's in the 17th column. That means it's -1. That makes sense because there's a 1 right there. It's not written in, but it should be there. Now, chlorine has a 4 subscript. That means this must have been a +4, just like that. So that means that the platinum has a charge of +4. So we're going to write that in. Platinum, Roman numeral 4, chloride then is our final answer. Okay? Platinum, Roman numeral 4, chloride would be the name of this compound. Let's do one more. This time we've got manganese and then chlorine, right? So manganese is going to have some charge. We don't know what it is yet, but what we're going to do is we're going to write the formula first of all, and we're going to try to determine from the formula what that charge is. Remember, this 2 came from here. So this was a +2. Chlorine was a -1 because it's in the 17th column, right? It's in the 17th column. So we now know what the charge is. It's 2. So we're going to write as the name manganese, Roman numeral 2, chloride, just like that. And that completes our naming of ionic compounds that contain transition metals. Okay, hope that makes sense. All right, let's move on. What we want to do is we want to now name what we call ternary compounds. What do we mean by ternary compounds? Well, these are compounds that have more than 2 atoms involved, right? So up to this point, we've done things like magnesium oxide, or we've done sodium chloride, things like that. But now what we want to do is we want to be able to name compounds that have what we call polyatomic ions. Now, what is a polyatomic ion? A polyatomic ion is a group of atoms which are bonded together and have a charge, just like a cation or an anion, right? So here's a list of some common polyatomic ions. It's not a complete list, but it certainly is a good representation of polyatomic ions. So let's take a look. If we've got, for example, C2H3O2, and the whole thing has a charge of -1, that's a polyatomic ion. More than, poly means more than, atomic means atom. Polyatomic ion with a charge of -1. Hydroxide has a charge of -1 as well. It's OH minus. Now, as you can see, most of these are going to be negative, right? Most of these are going to be negative. There are a few positive ones that we'll talk about later, but the point is this. The point is that polyatomic ions contain more than one atom, and they have a charge. Sometimes it's -1, sometimes it's -2. In the case of phosphate, it's -3. Notice, by the way, how they write sometimes, instead of -3, 3-. Get used to that, all right? It happens often, and we'll talk a little bit later about when is it technically supposed to be -1 versus 1- and so forth. But for right now, we're just going to say, for all intents and purposes, a minus. If they have a -1 or a minus or a 1-, all that's the same. 2- is the same thing as -2. Don't worry about that differentiation right now, okay? So that's what we mean by a polyatomic ion. So now that we've got this list, let's name some of these compounds, all right? We have CaCO3. Now we know this is a ternary compound because there are more than 2 elements involved. There's calcium, there's carbon, and there's oxygen, right? So how do we name this compound? Well, we have to recognize that this part of the compound, this CO3 part of the compound, is a polyatomic ion. And so what we have to do is look to see what that polyatomic ion is. CO3-, there it is right there. It's carbonate, right? CO3 2- is carbonate. So we're going to call this first one calcium carbonate. Calcium carbonate, CaCO3. Let's look at the next one. We have K, potassium, NO3. This NO3 is, that part of it is a polyatomic ion. What's it called? Well, let's look at the polyatomic ion chart. Whoops, let's go down just a bit here. Let's look at the polyatomic ion chart. NO3 is called nitrate, right? NO3 nitrate, just like that. So we're going to call this one potassium nitrate. Now this one's a little bit more complex. It's not too terrible, but it does have parentheses. That's not going to bother us. What we're going to do is we're going to recognize that this right here is a polyatomic ion. We'll talk a little bit about why the 2 is here to be in just a moment. But the point is this. MnO4 is permanganate, right? MnO4 is permanganate. Let's see if it's in this partial list here. MnO4, you see it? Yeah, it's right here. MnO4 -1 is permanganate, okay? So we're going to call it potassium permanganate. We're going to call it potassium permanganate, just like that. All right? Okay, so we now know how to name ternary compounds. I give you the formula, you give me the name using a polyatomic ion chart. Okay? All right, now, the next thing is this. Write the formula for the following ternary ionic compounds from the name. So here we go. We have copper, Roman numeral 2, sulfite. Copper, Roman numeral 2, sulfite. How are we going to do this? Well, what we're going to do is we're going to recognize that copper is a transition metal. It has multiple oxidation possibilities, or multiple charge possibilities, in other words. It can be +1 or it can be +2. The question is, which one is it? Well, we know the charge is +2 from that Roman numeral 2. So we're going to say, first of all, Cu +2, just like that. Copper is Cu. It's going to have a charge of +2. Now sulfite, let's go back up to our chart, and let's just find sulfite on our chart. It's right there. It's SO3 2 minus. Now sulfate and sulfite are two different things. Sulfate is SO4 2 minus. Sulfite is SO3 2 minus. We're going to make sure that we use sulfite. So SO3 2 minus. So I'm going to do this. I'm going to say SO3 like that. I'm going to put that in parentheses, and that's 2 minus. I could have said -2. Either way is fine. But look what's going to happen. When I do the switch, they're going to cancel each other out, and I'm left with CuSO3. So copper 2 sulfite becomes CuSO3, just like that. Okay? Does it make sense? All right, let's erase this so we can have that area to write on for nickel 2 hypochlorite. Nickel 2 hypochlorite. How would we write this structure or this molecule? Well, recognize that nickel has multiple charges or oxidation numbers, but this one's 2, right? So when we say hypochlorite, what we're going to do is we're going to say nickel, Ni, and we know it has a charge of +2, just like that. Hypochlorite is going to be this one right here. It's ClO, and it has a charge of -1. Whoops, -1, just like that. When I do the switch, a 1 goes down here next to the nickel, but the ClO for the hypochlorite gets a 2 subscript. So there it is, NiClO2. Now I want to ask a quick question, and that is this. I've got the 2 outside of this parenthesis, right? I've got a 2 outside this parenthesis. Can I rename this as NiClO2O2? Can I do that? The answer is no. This is not like algebra where I can distribute that 2. Okay, what this 2 means is that there's 2 of these ClO units. So I cannot distribute that 2. The formula would simply be NiClO with a subscript of 2, just like that. Okay. Okay. I think this is a good place to end here, and so we've made a good amount of progress in naming compounds, particularly compounds with transition metals and now polyatomic ions. And we'll call it quits for now. I'll see you on the next one. Thanks. Bye-bye.